Now it's time to calculate the weight and balance for this particular flight. We're going to start with this chart in the upper right-hand corner of the back side of the flight log. The first thing we need is the weight and empty moment of the aircraft. Using the US Aeroflight Aircraft Information Sheet for Skyhawk 80277, we can see that the basic empty weight is 1438.5. So we'll put that here under BEW, basic empty weight. And the moment, you can see here, the empty weight moment divided by 1,000 is 56.71. Now that we know the aircraft's weight and moment, we'll calculate the same for any other applicable line items. The first being passengers 1 and 2. That would be the pilot and co-pilot, or flight instructor. Let's say that you, the student, in this case, weigh 180 pounds, and the flight instructor weighs 200 pounds. That would give a combined weight of 380 pounds. Let's calculate the rest of our weights, and then we'll figure out all of the arms and moments. Let's imagine that backseat passenger, we're going to take along a 150-pound flight student who would like to observe our cross-country. Passenger 3 and 4 line will have 150 pounds. Passenger 5 and 6, we have none in the Skyhawk. Baggage area 1. If we all have our flight bags with us and we decide to put them out of the way in the baggage area, let's say that that's 3 flight bags at 5 pounds each, resulting in 15 pounds total. We won't use baggage area 2, which is the small elevated hat rack area in the back. And then fuel, we'll be starting with our full 38 gallons, which will times 6 pounds per gallon give us 228 pounds of fuel. Now, there's 2 ways we can calculate the moment. If we go to section 6 of the POH, that's weight and balance and equipment list. The 2 formulas we need to know for these calculations are weight times arm equals moment, and total moment divided by total weight is equal to the center of gravity. So if we look here, we can find the arms for various points in the aircraft, and then we can run our calculation. Remember that an arm is a distance measured in inches aft of the datum along the longitudinal axis. So the pilot and front seat passenger will be 37 inches aft of the datum. So here that passenger 1 and 2, we'll put 37 down as our arm. Now we multiply weight times arm, and we'll take 380 times 37. That results in 14,060. Since all of our moments are going to be divided by 1,000, that will be 14.06. Passengers 3 and 4 here in the rear have an arm of 73. So 73 multiplied by 150 gives us a moment of 10,950. Divide by 1,000 and we get 10.95. No passenger 5 and 6, so we'll skip that. Baggage area 1, we can see 95 inches after the datum is our arm. So 95 times 15 equals 1,425, or 1.4 when we divide by 1,000. No baggage area 2, and note this picture shows no fuel arm. However, if you turn the page to the sample loading problem, it shows that full fuel will result in a moment of 10.9 once we've divided by 1,000. Now we could reverse engineer what that arm will be. 10.9 times 1,000 equals 10,900 divided by 228 equals a moment of 47, an arm of 47.8. So we'll say 48 inches aft of the datum. Now we'll total our weights and our moments for takeoff. So 1438.5 plus 380 plus 150 plus 15 plus 228 equals a weight of 2,211 pounds, 2,211.5 pounds for takeoff. Totaling up our moments divided by 1,000, 56.71 plus 14.06 plus 10.95 plus 1.4 plus 10.9 equals 94.02. Now to calculate center of gravity, we take 94.02 and multiply by 1,000. Divide that number by our weight of 2,211.5 pounds. And we find that the location of the center of gravity is at 42.5 inches aft of the datum. Now we want to turn to this chart and find our limits. So we're going to weigh 2,200 pounds and we're going to have 42.5 inches aft of the datum. So we'll be out of the utility category both by weight and by CG location, but we're going to be roughly in the center of our weight and CG load limits, perhaps just slightly aft of center on takeoff. Now to calculate our trip fuel. For the trip fuel, we said we would burn 7 gallons. 1 gallon of fuel weighs 6 pounds, so 7 times 6 means we're going to burn a weight of 42 gallons of fuel, 42 pounds of fuel. And if we multiply by our arm of 48, that gives us 2,016, or a moment of 2. So for landing, we're going to subtract 42 pounds from our takeoff weight of 2,211.5. We're going to get a landing weight of 2169.5. Subtract our moment of 2 that we're going to lose fuel, and we'll have a new moment of 92.02. Take 92.02, multiply by 1,000, and divide by the weight, 2169.5. And we'll find that on landing, our center of gravity will be 42.4. So if we'll be burning 7 gallons of fuel in flight, we'll have 31 gallons of reserve fuel all told.